Now that the rough forging is done, we can start the heat treating process, and the first step in the heat treating process is to anneal the metal. Annealing is used to remove any residual stresses that might be left over from the forging process, and this step is critical when you're working on knives or anything that has a very large, thin cross-section. When you're annealing the piece, you have to bring the entire work back up to critical temperature. You have to heat this very slowly so that you don't overheat the metal, and then you allow it to cool as slowly as possible to room temperature. For most tools, letting it cool slowly in air is sufficient, but for some thin bladed tools you might want to stick it in some ashes so that it insulates it and prevents it from cooling too quickly. After annealing, you'll want to do all of the rough grinding that you need to do to the tool to get it ready for tempering. We're now ready to begin the heat treating process by heating the end of the tool that needs to be hardened up to the critical temperature and quenching it in oil, the same way we did with the sample earlier. The final step in the heat treating process is called tempering. Tempering removes some of the brittleness from the fully hardened piece of steel to give us the working properties that we're looking for. The really nice thing about steel is that it changes color as it's heated up. These samples show all of the color changes that happen between the temperatures of roughly 400 degrees to 600 degrees Fahrenheit. For centuries, these colors were the only tool that the smith had for determining the temperature of the metal. They're called oxidation colors, and the only time you see them is on a brightly polished surface. So as you heat the metal up, you are gradually removing some of the brittleness and making the steel more flexible. So at the low end of the scale, you temper tools that need to be very, very hard but don't require a lot of flexibility. And at the upper end of the scale, you temper tools that do not require a lot of edge holding ability but need to be very flexible, like springs. The colors intensify as they get hotter. Sample number 1 has had no heat applied to it. Sample number 2 is the lowest visible range that you're going to see, and it's approximately 430 degrees Fahrenheit. And it's usually identified as a light straw. Number 3 is 30 degrees hotter and is showing as a full straw color. In number 4, the straw color has turned into a light bronze. Number 5 is a dark bronze. In number 6, you start to see the transition from the bronze colors into the purples that you see in 8 and 9. And then the purple colors change slightly into the shades of blue, which are found at the very top end of the tempering scale. The last colors that you see on the oxidation scale are the light blues that turn into a gray. Drawing the temper to this color will leave the metal just a little bit harder than you started with before the hardening process, and there really isn't any practical application for this. Now those color samples were fired in an electric kiln with a very accurate programmable controller. You're not going to get anywhere near that level of detail when you're tempering a small chisel with a torch, but I just wanted you to see how the colors transition from one to the next. Tempering in the shop usually involves using a torch to heat up a section of the tool that's away from the edge that you want to temper. As the heat builds up, you're going to start seeing the colors appear on the polished surface. When I start seeing the colors, I'm going to remove the torch and let the heat that I've built up in the base of the tool push the colors towards the tip. At this point, it's just a matter of watching the colors move towards the tip. If I feel they're going too fast, I'll remove the torch and let the thing cool down so that the colors will slow down and the bands will widen out. If it's moving too slowly, I'll apply the torch a little bit to try to move them along. It's really just a matter of experience, but once you've done a few tools, you'll get the idea. The key is to make sure that you take your time getting the first colors to appear. You want the whole tool to be hot. You don't want the colors to just run along the surface because the surface is at the right temper color. That'll create a tool with a soft exterior, but the center of the tool will still be brittle. That'll cause it to fail. Here you can see all the temper colors are jammed into a little 1/4 inch band. This happens when the handle end of the tool is really hot. You have a good bank of heat being built up, but the front edge of the tool is still too cold, so all the colors are being jammed into a tight space. As you remove the heat and let the temperature even out, you'll find that the colors will start to move forward, but the bands will get wider and wider. You are trying to get the temper color at the tip, but you also need a fairly wide band so you can sharpen the chisel a few times before you have to redo the tempering process. Also, when I'm testing a temper color on a new piece of steel that I'm not familiar with, I'll tend to leave it a little bit hard. That way, if I get any chipping at the tip, all I need to do is reheat the metal and continue the tempering process and move the next temper color into the tip to soften it. I don't have to redo the whole hardening and tempering process. When you have the temper color that you're looking for, you quench the entire tool in water. This stops the tempering process. This tool is performing a lot better than I was expecting it to, so now all I have to do is try to remember where I got those springs.